Alright, so let's go through the directions here. Again, when I stop, you guys are all reading the next word, so we're following along, we're paying attention. So when I stop, you guys are reading the next word. Here we go. So it says, you have explored how the linear equation y equals x is to create the equation y equals x plus b, or to create the equation y equals mx. In this, you will combine both and translations to graph of the form y equals mx plus b. Now, we've already talked about several things that were mentioned in the directions. So the first thing that I'd like for you to do is I want you to come down to the very last part and put a box around y equals mx plus b. So this is an equation that we've talked about before. There's a couple things we're going to do with this. So the first thing I want you to do is I want you over to the side to tell me the name of that equation. So you're writing the name of that equation. So I'm going to give you a second to write it. Okay, so on 3, we're all going to say the name of the equation. We need everybody participating. Ready? 1, 2, 3. Okay, so we should have said slope, intercept, form. Okay, so we've talked about that. The next thing I'd like you to do with that equation is draw a little line from M and draw a little line from B, and I want you to write what M and B represent in the equation. What M and B represent. Okay, go. Okay, so we're going to partner share here for a second. Partner 1s, you're going to tell your partner what M represents. So partner 1s are doing M. Partner 2, you're going to tell your partner what B represents. Okay, ready, go. Okay, so let's talk about some answers we should have said. So M represents the slope. Hopefully we got that. It's also, when we talk about it, we want it as a fraction. We've talked about that before. Okay. If they said anything about y over x or rise over run or anything like that, that is fantastic. Okay, let's go to B. For B, remember that is the y-intercept. So that's the important thing we had to have for B. 2 other words I want to pick out of the direction that we've heard before are translated. So underline translated. The second word is dilated. So translated and dilated. Over to the left here, I want you to write those 2 words. Now you're going to give yourself some space here. So you're going to write translated. Okay. Skip a little bit and write dilated. So again, we've talked about translations and dilations. So it's the same thing that they're mentioning here. Translations and dilations. I want to see what you can remember about translations and dilations. So you're going to write, just give me a couple words or a quick definition. Now remember, for translation, we have a one-word definition that we've talked about. So I'm going to give you about 30 seconds. I'm going to set my timer over here. Write down anything you can remember about translations and dilations, for translated and dilated. Go ahead and start. Okay, so partner 1s, you're going to share what you came up with for translation or translated. Partner 2, you're going to share what you came up with dilation or dilated. If you're a partner that couldn't come up with an answer, that's okay. You're going to use your partner's answer to help you. Okay, remember, 1s are saying translated, 2s dilated. Go ahead and start. Okay, so between the two of you, hopefully we got some answers here. Let's go over some things that we might have heard. If you remember back, our one-word definition for a translation or translated was a slide. Okay, so you're sliding the figure. When you slide a figure, everything stays the same. They're congruent. Our pre-image and our image congruent. Our line, if we slide a line on a graph, congruent. Same thing there. Okay. A dilation, and actually we're going to backtrack. If you don't have the word congruent here, I want you to put congruent. So remember, congruent means same size, same shape. So it's a slide, stays congruent. For dilation, remember that's either an image getting enlarged or reduced. Now remember, with a dilation, our answers are not congruent, or our figures or our lines are not congruent, but they change size, which makes them similar. Okay, so they change size, so they're similar. So now that we've kind of looked at some previous knowledge that we've talked about, let's look at question 1 here. So question 1 says, consider the set of equations. So here's what it's meaning. Here's what I want you to do. I just want you to look over those 4 equations. After you have looked over them, you're going to answer question A. Question A reads, what do all of the equations have in common? Now, we had a question like this on our skills practice in block 2. So for those of you who are in block 2, it's kind of the same thing. So it's saying, what do they have in common? When you answer this question, I want to see vocabulary that we've used. I want you to be specific, and I want your answer in a complete sentence. So I'm going to give you about a minute here. I'm going to set my timer for a minute. You're looking at the equations and a sentence for what they have in common. Go. So if we look at what all of these equations have in common, the number that's sticking out in all of them is this number 2. So all of them have a 2 in the equation. Now this 2 is in a certain place. We've talked about this place before. So this 2 represents the slope for our equation. So when we look at what they all have in common, you needed to have a complete sentence telling me that all of these equations have the same slope. So all of the equations have the same slope. Remember, this needs to be a complete sentence. So you have that already, that all of them have the exact same slope. Now remember, we've talked about that I prefer you to write slope as a fraction. So the next thing I'd like for you to do is change all of these 2's to a fraction. So all of these 2's here need to be changed into a fraction. Okay, so I'll give you a second to do that. Okay, so you guys are going to help me out. On 3, we're all going to say what number you put in the denominator to make a whole number into a fraction. So anytime we want to make a whole number into a fraction, there's a certain number that goes in the denominator, which hopefully you just got. So everyone's going to say that number on 3. Ready? 1, 2, 3. Very good. So we should have said 1. So you're changing all of these to 2 over 1, 2 over 1, 2 over 1, and 2 over 1. So B says use transformations to graph each equation on the coordinate plane. So remember, we talked about transformation up above. All transformation is a slide. Now let's start with our first equation up here. So we're looking at y equals 2 over 1 x. So we've talked about if there's no y-intercept, if there's no number over here at the end, so there's no y-intercept, then our first point should be at the origin, 0, 0. So I want everybody to do that. So put your first point at the origin. Okay? Now our slope, remember, is y over x. So we have 2 over 1 in place of y over x. So we have 2 over 1 right here. So remember, the 2 tells us our rise, or our up and down. The 1 tells us our x, left and right. Okay? So I want you to go ahead and finish graphing that line. Alright, so remember that positive 2 tells us we're going up 2 from our origin. Positive 1 tells us 1 to the right. So we're going up 2, right 1, and we make a point. Now remember, I've taught you guys that I want 3 points on your graph, so we do the opposite. So instead of going up 2, right 1 from the origin, we're going to go down 2 and left 1, and we're going to have our points. So if you haven't already, I want you to go ahead and connect them all the way through the graph. So you have a line that looks like this. Okay? Now, if we look down at the second equation, the only thing that's added to it is this positive 3. Okay? Now, remember, we're using transformations. The transformation we're using is translation, which is a slide. So we've talked about that before. Translation is a slide. So all we're going to do is we're going to slide our line. So we're sliding this line that we've already made up to be at positive 3. So instead of having this number, this point right here at 0, we're going to slide it up to 3 and put a point at positive 3. Okay? So we're taking this point that's at 0, our y-intercept, and moving it up to 3 and putting a point at positive 3. So go ahead and do that. Okay? Now remember, the slope is the exact same, so we're going up 2 and right 1 from that point. We're getting our third point by going down 2 and left 1. Okay? And go ahead and connect those. Alright, so we should have made 2 lines that are not touching. So on 3, you're going to tell me what you call 2 lines that would go on and never touch, say the same distance apart. Okay, so there's a name for this, and we talked about this the other day. So on 3, we're going to all say the name of what these 2 lines have just made. Ready? 1, 2, 3. Alright, so we should have said the word parallel. These are parallel lines. Okay, let's go down to the next equation. So instead of positive 3, we have negative 5. So again, it's a translation, so we're sliding. So again, instead of being at 0 for the middle in the origin, we're going down to negative 5. We're going to point at negative 5. Okay, so here's what I'm going to give you some time to do. You're going to finish graphing this line with a slope of 2 over 1. Then you're going to do our very last equation that has our y-intercept at positive 5. So we're sliding this up to positive 5 up here. Okay? Once you are done with that, you're going to come down here and you're going to answer question C. So your job right now is to finish graphing the third equation, do the fourth equation, answer question C in a complete sentence. Okay? Go ahead and start. Alright, so you have this quadrilateral, and the question had asked us if this was a parallelogram. Remember, a parallelogram has to have 2 sets of parallel lines. Now, as we look at this, we can conclude that the top line, line C to D, and the bottom line, A to B, we can conclude those are parallel because they're straight across horizontal. Those are kind of the easy ones to see that they're parallel. Okay? But it's line A to D, so this line here, or D to A, however you want to say it, and B to C, those diagonal lines are the ones that we have to decide if they're parallel or not. So in order to do that, remember what we've already concluded from today is that parallel lines have the same slope. So your job is to figure out what is the slope for line A to D and what is the slope for line C to B, and see if they're the same. If they are the same, that means the lines are parallel. If they're not the same, they're not parallel. Go ahead and work.